welcome. We are going to be talking about JavaScript. So let's just dive into it and start at a place where backend devs would be comfortable at. There is going to be a lot of code, so I hope that makes you happy. All right, so we do have a repository right here, a repository that lets you get a list of things. Sounds pretty standard. And let's say we get a new requirement where we have regulatory, some government decided letter A is illegal. So what we might do in a backend world, we create a censored repository. How we might implement it is usually it's going to be inheritance. So in this example, we have wrapped our function, passed in a function to a function, mapped results, pretty standard stuff. And now let's try making this code look a little bit more like JavaScript. First thing base is super, so sort of like Java, makes sense, JavaScript. Next thing is constructors don't have names, we don't have colon, we have extends keyword. And of course, the most controversial thing, I know for us backend devs, that's horrifying, but that's the convention. So that's what I'm going to be using for the rest of this. So we have some nice JavaScript code, and let's try running it. Did we expect an error? We didn't. Did we get an error? Of course we did. It's JavaScript. Why did we get an error? We hopefully will find out during the course of the next hour or so. And next, what I would like to show you in this code is the hack that usually was used for this case, which works. Why does it work? Also, we hopefully will find out. And while it works, it does come from misunderstanding of how the language itself works under the hood, which sort of fair enough, it does work different than what we're used to in backend. So what is our agenda? The talk is dedicated for backend devs, like it said. I'm hoping to get or give you more intuition about JavaScript because we're working with it. So it would be nice to have a bit of idea what actually happens behind the scenes, as that will decrease chances of weird bugs happening. And our scenic route is a lot of code. So as I said, so to start, we cannot start talking about JavaScript without a little bit of history, because it does reveal, in my opinion, the main theme behind JavaScript. So it started way long ago, before Internet Explorer was a thing, and Netscape Navigator was the de facto browser at that point. And Netscape hired a guy called Brendan. They wanted him to make websites be more dynamic, not just HTML. And Brendan was an academic. He loved functional programming languages. And his favorite one was Scheme, which looks a little bit like this, pure functions all the way. So he did implement it in Netscape Navigator. He had nice dynamic websites. But they came to him and said, do you know what? We don't like the syntax. Like most people are using Java right now. Do curly braces. So he modified the language, still works the same. And they called it LiveScript. But of course, Netscape, being market-oriented people, said Java is all the rage now. So we sprinkle on a little bit of marketing and we have JavaScript. And the last point at our history lesson about JavaScript is later on, after many different run-ins with Microsoft about actual standard of what the JavaScript language should do, they did submit it to ECMA, which is some standardization body. Not even sure what the acronym stands for right now, I forget, but it's European Computer Manufacturers, something or other. Doesn't matter. Standardization. ECMAScript is JavaScript, just another name because why not? And that concludes. And like I said, for me, that shows a lot of things that are happening in JavaScript, which is pretending to be something you're not. So we've said that everybody knows that JavaScript is not really Java, but let's see if it's actually a script as well. So let's start with scopes. We have a function, we have a variable. Variable is accessible in the function, we can print it. Of course, we can override the variable and we will have the overridden value. And now the first trick question, what happens right here? We would expect to print value because we've not overwritten it yet. But what happens, we will have undefined because the JavaScript is not really a scripting language. It is interpreted, but it's not being run top down. It is first pass basically is a parser. So function print does have a var variable inside it. It doesn't matter that we've not run into it while running, but the lexical scope, so-called, already has taken into account that this variable is part of this function's scope. So it does already cover the global scope variable, it's just not assigned to yet. In the same manner, we can sort of use this fact to use what it's called hoisting, which basically means you can put all your functions at the end and just use them, which some people like because it makes more order in your code. Next thing is what would we expect right here? And I would say that variable is not overwritten right now because it's in a different scope, sort of, right? But turns out, no, it's in the same scope. Because turns out curly braces are not a scope. Function is a scope and only function is a scope. And that's where let and const come in. Because ECMA, JavaScript people, designers decided that that doesn't make sense to people, that curly braces are not a scope, so they added a keyword. And right now, most of us actually only use consts and lets, which is a good job because that makes more sense to our backend brains. That's good. Now let's go to closure. Closure is very important in functional languages, but I think we all have intuitive grasp of it. Because if, for example, we use link like select, that's exactly what this map does. So we have an array which we map over a function. We can try to implement that ourselves to see what's happening under the hood. It's basically going to be a for loop outputting an array. Every element has been run through that function, and that's pretty much it. So let's extract that function. I'll show you why in a second. And let's say we have a factory for that function. So now what happens, and it still works because why wouldn't it, is this function has access to the times variable, even though it pretty much should have been destroyed when going out of the function's scope, right? But turns out closure, which is something that came from functional languages, and believe it or not, C# didn't used to have it at some point. It was a feature added. It basically means that a function will have access to the scope at to this lexical scope, basically. So first time parser sees what the function uses, and all those variables and values get essentially packed into a backpack, and the function takes the backpack with it and goes on its merry way. Sounds, well, technical detail is a bit confusing, but I think for us using link all the time, that should be a bit intuitive. Now let's talk about what a function expression is, because that will be obvious for us in a bit. A function expression essentially, so let's first talk about, we have a map over a function and we want to actually pass that function in as so-called first-class citizen. We can create a function like we did in the example before, or we can create a variable and assign function to it. And essentially what a function expression is something that is not in scope. It evaluates into a function you can run, but is still a variable. And why are we talking about this? Even more seemingly useless example, there's something called immediately invoked function expression, and it is important enough that it has its own acronym and name. So yes, it's not as useless as it seems. Essentially what we're going to do, we have a function, we're going to wrap it in parentheses, which means because the line didn't start with function or var or let, this thing is not inside of this scope. So essentially right here we have a variable that is not assigned to anything, so reference error function does not exist. But we can immediately invoke it, which seems pointless, but we'll see that it's not as pointless. So let's see how we used to do code splitting in olden days. So let's say we have a counter application. I do not have a visualization of this, but the code is simple enough. There is a function onClick that assigns to an HTML an incremented counter. Well, nothing much complicated. And let's say we want to extract that function into a separate file. So what HTML lets us do is import that file from a separate source, which lets us keep multiple different files and not one file that's, for example, thousands of megabytes. But let's say our page is not as simple as just having one counter. Let's say we have some form on it. That form JavaScript file will contain in it somewhere a function with the same name, and we have a collision, which is a real problem. Because if everything is in global scope, collisions are a real possibility and really easy to come across. So let's do an iffy, because if we already talked about it, we might as well use it. So we have an immediately invoke function expression. Because it is an expression, it can return an object. We can capture that object, and then we can explicitly use the object return from that file, which basically means we now have a module code called counter. That module will have private variables. So we have encapsulations, and our collision disappears, because then we could do the same to our context form and have separate modules with separate names. Of course, we still can have module name collisions, but we don't have to worry about collisions other than module names, which was really nice. So that was what people used to use. I believe for a lot of time, Webpack did compile all modules to that pattern exactly. But of course, JavaScript does not run only on the browser. What this application does is not much important. It's basically a JavaScript file that runs without HTML. So again, let's try extracting the file to a separate, the code to a separate file. Let's wrap it in a module. And now we have a question to ask of ourselves. How do we import it into our index.js? Because how we used to do it in HTML was script tag, which we don't have HTML, so what now? And now let's go on a little thought experiment. And I think my teams are doing something weird. You don't see my animations, but hopefully you'll be able to see that we are basically adding a module object inside of our iffy. We are assigning export property to that object, and that's all our module exports, and we're returning that module. So that's not necessarily the easiest way that they could have done it, but let's say the module could be passed into that with some other properties. That's essentially what it's for. But any module that we create would essentially be of the same structure. So we could hide all the code that we duplicate. And in the I'm sorry, struggling on my animations being a bit wonky on my side. But on the side of our index.js, Node essentially implemented a require function, which points, we can point it to a file, and it, maybe not literally, but essentially will wrap that that file with an iffy, with a module. You get the exports in the file right here, which not only lets you now pull dependencies from different files, but also you get rid of collision problems, because you can rename that that's import. Well, essentially, you could do beautify as something else, and then you would have a different name for it. All right, so we have importing, we have solved the collision problem essentially, and that's when npm exploded, because right now you could create a package and not worry at all about collisions, and everyone can use it. So that's essentially what they called it CommonJS, because it allows you to use the same pattern in every single module, and everyone in the world could use it so long as they used it in Node.js. So now let's see what the response to that, well, getting rid of collisions essentially, first off was in the browser world. So you don't necessarily need to focus on AMD. I'm just going to show you what they are, but we don't use them anymore, pretty much. But if you find something that you see here, you will know that it's AMD. So problems of CommonJS are it's synchronous, because that require function does not have an await, so you're pulling files synchronously. It is only in Node.js, like we said. One more problem is that you can just pass a string as a file name. That's a Pandora's box of itself. And solutions to that might have been AMD, which essentially is one JavaScript file that defines defines a define function and a require function, so that you could, in simplest terms, put your modules and ifs and wrap your module pattern in string names for your modules, which sort of allows you to play a little more with what depends on what. And the biggest plus of the solution was that it was actually asynchronous. So people did start using it in browsers. And there is some additional tags in the script tag, but by convention, I believe it is by convention that this is the file name in the folder. So you're not distributing anything, you're not pulling anything from Node.js. You're essentially putting and hosting all the files in a folder next to require.js scripts, and that pulls together all the dependencies, which is nicer than what we have with just script tags. But we also still have the Standardization Association, who came up with the following syntax, which I could glance over because we pretty much all have idea of what it looks like. It's the de facto thing we use right now in front end, which is essentially export and import keywords, and that was implemented in browsers. And you can now see, for example, let's do simplest possible node module package. Perfect engineering approximation of number pi, which we can then use when we apply a type module to the script. We can just use the import and export keywords right here and there, here in your HTML, for example. But you could also use the import keywords in separate files if you so wish to code split. And then you can import that file like we used to by source, just specifying that it's of type module. So that essentially, like we see, gets rid of collision in the browser, and looks a bit nicer than AMD. That's essentially why no one sees AMD anymore. So Node tried to implement ECMAScript modules in itself. So for a while, there used to be this, or still is, essentially this problem that you would see MJS and CJS files, which essentially means if something is CJS, it can use require keyword. If something is MJS, it can use the import keyword. That's the gist of it. But that's a little bit wonky. So like we could do module type in a script tag, so we can now in our Pocket.json in our Node project, essentially config file, specify that all of what's happening in this folder is by default a module. And so we can now use our code in the browser, in the console, on the server, everywhere, which if you think about it, that should be CommonJS, but it's because it's more common. But it is ECMAScript module. It's standardized. That's the de facto thing. We don't really use anything else at this point, unless it's legacy. At which case, you could import it from a CJS file. They do try to make it sort of cooperate with each other. But do remember that CommonJS is synchronous, so ECMAScript does also give you performance benefits. So that's it about modules. Yeah, being happy about it running everywhere. That's it about modules, and let's talk about object-oriented syntax in JavaScript, the most misunderstood part, I would believe. So let's say we have a C# class. We have an implementation of that C# class. It has one method, one variable passed in by a constructor. Let's for a second look at a Python implementation, and I'll say why in a bit. Looks pretty much the same. One exception that Python has that I've not seen in many other languages is the self thing. We don't have a this that's tied to a class. We do have a self that's tied to a class, but you do need to pass it in as the first variable, which to me pretty much explained what that this is in in compiler time, because it essentially is a hidden passed in variable, which is the thing on the left of the function. So you could think of any function or any method on a class as being just a function, but the thing on the left of the dot is being passed as the this. That did help me a lot when learning object-oriented first time. So let's look at what we could do in JavaScript. We have a function, we pass a variable. We want to have a function on that object that comes out from the animal function. So what's the implementation? We have an animal function, takes in variable, returns an object. That object should contain a function, and that function should print essentially the voice. So what we can do, the simplest thing, closures. But there is a trouble with what we've done right here, because by using closures, we are losing an essential part of what object-oriented programming gives us, which is reusability of methods. Because essentially that whole method, the signature of it, it gets compiled one time and then passed around because we are passing in the self. And here, every time we run or create a new object, we will create a new function that needs to be evaluated, performance issues, garbage collection, mayhem. So let's try extracting that function outside. But of course, voice does not exist right now. So what could we do? We could use a this. Because let's see, we will have a speak inside the object. We use it on that object. So this is essentially what's on the left of the function being called. That's why I showed you the Python example, because it is essentially the same thing, except the function is not defined on inside the class. It just lives by itself. But this does the same thing. So is there any more to say about this? I guess no. It's yeah, like I said, essentially it is the left side of the dot. There are some other cases, but this is where it comes. This is where this comes from in JavaScript. So if we pass the variable, it's no longer undefined. So like we've seen, this is a doc that has a voice. We need to print it. It gets printed. Let's do a little bit of the structuring magic. So that syntax with the structuring is essentially creating an object, assigning to it, and returning that object. We could do this and assign to it and return it. It still works. I wouldn't recommend it because this, without it being called on something, is window. That's helpful from JavaScript, so you wouldn't have an empty object. But we also could use a magical new keyword, which one of the many things it does, it is creates a new object for you and passes it. So again, it is essentially, this will be what's on the left of the function in some convoluted way, but that's JavaScript. All right, so let's see. Like I said, there are some other places that this can come from. But essentially, first one we've already discussed is on the left of the dot where it's being called. You could, for example, have an object that doesn't have this function, but you could use a method of that function, because functions are also objects of some type in JavaScript. Use a method called call and pass the object, which will then be the this in the context of the function. We could also have an object we could bind to that function, which essentially what it will do is it will recompile, not necessarily literally, but in essence, the effect is a recompile function where the this is replaced by var_c. And then you could call that function, because what bind does, it creates a new function for you. And I believe the bind one is the one I've seen most in old React code, maybe. I might be wrong. But yeah, we need to be careful about understanding what those things do when we see them. I wouldn't recommend putting them in our code, because confusion bad. Now, most interesting parts of the most interesting parts, prototypal inheritance. Let's ask yourselves what a prototype would mean. In my eyes, a prototype is a template, so something you base your new objects on, for example. Inheritance would be copying structure of something else, like sort of in real life, your children would have a lot of the same things you have by a copy operation, essentially. And when you use inheritance, you essentially say, I can do the same thing you can do. Now let's contrast it with delegation. So inheritance versus delegation, it's like power of attorney. You have a guy that does things for you. You don't essentially are able to, but I have a guy for that. And let's contrast prototype with a reference. So, well, a reference in this case would be my guy's number, right? And why am I going on this funny journey is I will do a cheeky thing, and for the remainder of prototypal inheritance part, I will add a tiny translation on top of it called, well, prototypal inheritance means referential delegation. It does. It is delegation patterns. So what I believe makes prototypal inheritance most confusing to us, it sounds like object-oriented. It is not. So let's go. What is the basis of it? So every object in JavaScript can have a super secret super property called dunderproto, which will be the guy that we can ask stuff of him. So if we go object A, we have A, object B, we have B. If we ask for something that the object doesn't have, instead of immediately telling you, I don't know, it will tell, I don't know, but I have a guy. And my guy, do you know? I do know. Right, we can transparently pretend we did all the things, but we have a guy for it, so everyone's happy. And now we don't necessarily need to define the whole object in the object. We can put it in as a reference, which allows us to reuse. So the guy can have essentially multiple clients, right? More people can want to know what C is. So in this case, we have no properties. A understandably is undefined. B and C, my guy knows about B and C. Everything's fine. My guy also can have a guy. I won't know about it, but if I ask for C, my guy will go, hey, my guy. That gets confusing. But yeah, that's what we call a prototype chain. So reference delegation chain, essentially. But yeah, called prototype chain in the books. Next, we have a object that has 2 layers of delegation, prototypes. And let's see what it looks like in Chrome DevTools. So we have that exact same object. We are expanding on it. It will only tell us it has A and B because everything else lives on its prototype. So I would still be hesitant of calling this prototype because that still makes things a bit confusing. Like I mentioned earlier, that's a reference, that's the number to the guy. And it's a super secret restricted number, so it's called different and it's hidden from you and you never see it, but it's there. So your prototype will have some properties and a prototype, well, a reference, a number to the guy. And the last guy will have a reference to an object, essentially, which makes sense to us because every object inherits from base objects. And so in referential delegation, every object at the end delegates to a global object. And that object will have an interesting property, which is a constructor, which again does similar things but confusing confusion, and we will see what that constructor essentially is in JavaScript. So let's say we have a function and we're using our wonderful new keyword that will make our object have a constructor. And if we call that constructor, we will see that it's the same function. So let's take a peek in DevTools. We have an object, it has a prototype, and constructor of the prototype is this function, which conveniently JavaScript or DevTools will no longer say object here, but the name of the constructor, which is pretty useful, if I do say so myself. So your constructor will be the function that made you, makes sense. But of course, it doesn't live on the object it's referenced. So let's now peek at the function itself. Function itself has a prototype, and that's the actual prototype. That's why I'm hesitant of calling anything else a prototype. This is the prototype. So function, when being first created, will have or will define the guy that can do the things that any constructed objects need to be aware of. So this constructor, essentially, well, this constructor prototype will be the same exact object as our super secret reference from an object. What that means also is that if we create two different objects from the same function, their reference, their guy, their number to the guy is the same number, it's the same guy. That's the, I believe, biggest difference, is that you are reusing an object, not reusing code, like in actual inheritance. So let's use our new knowledge in our animal example. We have a prototype, so animal will define a guy that knows of animals, and that guy will be aware of all like baseline animal-ish things, like how to speak. And what that also gives us, we can remove the speak function from global scope and clean up a little. And let's also, having a chance, discuss about what that new thing actually does. So let's try to implement our own. We will pass in the function that needs to be the constructor and the arguments to it. What the implementation would look like. We have the constructor, we have parameters destructured, so it's like params array. We create a new object, that's one. We call the constructor, so that's why I talked about this, because I need to use this right here. We are calling the constructor function, but forcing its context to be the new object. We are giving our new object the number to the guy, and we're sending it on its merry way. So that's essentially the algorithm of creating objects with the new keyword. So it's sort of important to remember that all this magic is inside the new keyword. So if you call your function without the new keyword, which you can do, you have problems. JavaScript helps, right? So we are sort of coming to finish line. And we will talk a little bit about, well, tiny bit about classes. So let's say we have a square that extends shape, normal inheritance, things we know from all our years of experience. And let's contrast this with just functions. So how would we pretend that we are doing inheritance with our functions? So essentially what that would mean in extends case is that a square will be able to do everything that a shape can do, which would mean that a square function needs to define the guy, the expert, and that expert needs to be able to do all the things that expert for shapes can do. How do we achieve that? We give him the number. So our square expert has the number to shape expert. Every new square, new object, if asked to do square type things, will ask the square type guy. And if they're asked to do shape type things, it will ask the square type guy, who will ask the shape type guy. And this is essentially what really happens under the hood. If we look at DevTools, find two differences. There are two. So essentially, it is true that class is just syntax sugar. I've learned during this talk that even though I thought some things in class syntax aren't sugar, they actually still are, because well, still, even though it looks like inheritance, it's not. It's delegation. It's hidden really well. I was trying to find examples where it's easy to shoot yourself in the foot where using class syntax and it doesn't behave. It's easy to find where this doesn't behave because we don't really understand that class isn't really the top level for this this context. It's the function that defines it. But the class syntax sugar seems to be almost watertight at this point, which is really interesting. But still, it's good to know that it's not what you think it is. It's linked objects under the hood, reused code. Yeah, confusion as per usual with JavaScript. So what we have talked about is lexical scope. So Java is not only not Java, it's also not script. Immediately invoked function expressions, funny name. ES modules, which are next step evolution of those. And like I said, I do believe Webpack for a bit did compile ECMAScript modules into a module pattern before Node implemented ECMAScript. I might be lying, but it's some ethereal bits of knowledge that seems to be somewhere in my head. This awareness, which like we've seen, is scoped to the function. Prototypal inheritance, which is neither, like JavaScript, is neither Java nor script. Prototypal inheritance has nothing to do with either. And class syntax sugar was our icing on the cake. And I thank you and await your questions.